So this is the circuit belongs to the single phase full wave converters when connected in series. And the transfer ratio here, that is N1 by N2 equals to 2. This is the converter 1 and this is our converter 2. Since there is no freewheeling diode, one of the converter cannot be bypassed and both the converter must operate at the same time. In rectification mode, one converter fully advanced, that is alpha 1 equals to 0 and the alpha 2 is between 0 and pi. So this is my Vs, input voltage source, this pi and 2 pi, it's a sinusoidal wave. Then V0 1 or else voltage across the converter 1 is going to follow the entire voltage as the alpha 1 equals to 0. The second converter is going to operate at alpha 2, which is in between 0 and pi. Here T1 dash and T2 dash is going to operate. Here T1 and T2, here T3 and T4. Then in the negative half cycle, due to the inductive load, the negative peak will appear, and then at pi plus alpha 2, again T3 and T4 is turned on. The input voltage is going to appear across the output, and this cycle is going to repeat at that V0 equals to V01 plus V02. Now if you add up these two, and the first 0 to alpha 2, this is positive 1 and this is negative 1, gets cancelled, average value is 0, and here it's going to add up, then and here also it gets 0, and here it's add up as the current through the converter 1, positive half cycle, then negative half cycle. This is our I1, and the I2 is negative. It will be negative up to here, then it will be positive up to here, then negative. Now here I1 plus I2, between these two, this is negative value and this is positive value, will be 0. Then this is 2 times up to here, and here it is positive and negative gets cancelled, and here it is 2 times. And I0, current through the load, is always present, since the I1 is present from here to here and I2 is also present. A load current is continuous. Now, for a full wave converter, we know that VDC 1 equals to, or average output voltage equals to 2 Vm by pi cos alpha 1, and VDC 2 is given by 2 Vm by pi cos alpha 2. Then V0 is given by, that is VDC 1 plus VDC 2, that is 2 Vm by pi cos alpha 1 plus cos alpha 2. And this value is maximum. VDC max equals to, when cos alpha 1 equals to 1, cos alpha 2 equals to 1, we are going to get the maximum value, that is 4 Vm by pi. This is the maximum output voltage from this setup. Now in our case, we have taken that alpha 1 equals to 0 and alpha 2 equals to alpha 2. So alpha 1 equals to 0, which is nothing but cos 0 equals to 1. Then this will be V0 for our case will be 2 Vm by pi 1 plus cos alpha 2. V normal in our case will be, this is our output voltage divided by the maximum voltage. We are going to get 2 Vm by pi 1 plus cos alpha 2 divided by 4 Vm by pi. So V normal in our case will be 0.5 1 plus cos alpha 2. Now in inversion mode, one converter is fully retreated, which means the alpha 1 equals to alpha 1, whereas alpha 2 equals to pi. The Vs here will be having the sinusoidal waveform. V01 turned on at alpha 1, and due to inductive load, negative peak, and again alpha 1, this is our V01, and V02, since it is turned on at the pi, and only the negative voltage is going to appear. That is going to repeat. V0 equals to V01 plus V02. If you add these two are negative, and you can add this, then you are going to get more output voltage, whereas this is positive and this is negative, which will be 0 up to here. Again this is going to add up and 0, and this process is going to repeat. Now the currents. I1 is going to present when the V01 is present. Here up to alpha 1 it is negative, and then it's going to be a positive up to pi, and then negative. Then I2 is going to present when the V02 is present, and that is a negative value. This is a I2. The combination of these two, negative and negative, will stay. Here negative and positive will be cancelled. Positive, positive will add up here. Negative and positive, 0. This is our IS. Average output voltage VDC, that equals to V0 equals to 2Vm by pi cos alpha 1 plus cos alpha 2, and the maximum value of VDC equals to 4 times Vm by pi. But in our case, that is alpha 1 stays and alpha 2 equals to pi. If you substitute these two in the above equation, then you are going to get alpha 2 is pi, which is nothing but cos 180 degrees, that is minus 1. Then alpha 1 will stay. Then VDC or output for our case will be 2Vm by pi cos alpha 1, and this is minus 1. Then V normal equals to, this is our VDC, that is 2Vm by pi cos alpha 1 minus 1 divided by 4 times Vm by pi. That is 0.5 cos alpha 1 minus 1. This is our normalized output voltage.